Okay, so we're talking about line segments today. You guys remember what those were?
Yes.
Yes.
What?
They're lines that end on either
Because
side.
I keep going.
Yeah, it stops on both sides. So one of the ways we're going to talk about them is using number lines. Let's make this one a little bit longer. So if I wanted to, by the way, a number that gives you a location, like on a map or a coordinate plane, is called a what? Coordinate. So you guys remember, like when we were graphing last year, we had the x and y coordinate plane.
Yeah.
Those numbers that give you locations are called coordinates. So in real life, what are some kinds of numbers that gives us location? Like outside of math. Latitude and longitude, yeah, that's an example. Like if you have a GPS, it'll tell you this many degrees north, south, east, west, whatever. Those are coordinates. Okay, if I wanted to find, let's say this is A, let's put it right there. That's A and that's B. So how do I find the length of this segment AB?
You count.
Okay, you could count, but what if it was like 2 to 27? You don't want to count that. Okay, you would subtract. Okay, by the way, if I want to represent the length of segment AB itself is just this from here to here. If I want to represent the length of the segment, I could just say AB without any symbol on top. Okay? Yeah, you would subtract. So it'd be like 7 minus 2 is 5. Oops, is 5 long. Okay, what if I subtracted backwards? Would that give me the right answer? 2 minus 7? Well, almost, right? So if it comes out negative, you just make it positive. Because you don't say the distance from here to Tulsa is negative 37 miles. You just say 37 miles. So just make it positive. It doesn't really matter if you subtract backwards. You'll still get the right value, but you might have to make it positive. Okay. So what about if I'm going from, let's say, segment CB? How would I find the length of CB? Does subtraction work still?
Oh, you know what?
7
It does actually.
minus negative 2
Yep,
is
9.
9. Is that how long it actually is?
Yep.
Yep, 7 from here to here plus another 2. What if I subtract backwards? Does that work? Negative 2 minus 7, negative 9. So yeah, it does still work. Okay, so all you have to do to find the distance, find the length of a, if it's on the number line, you just subtract the difference. Subtract. Okay, another thing we're talking about today is midpoint. Guess what that means?
Point in the middle of the.
Point in the middle. The midpoint is going to be between, like, let's say if, what letters did I use up here? Probably not the midpoint. If D is midpoint of segment AB, then guess what is true? So here's segment AB. If D is the midpoint, guess what we know must be true?
A, B, or E.
Close. You're close.
A, D, B, or E.
Right. Did you hear what he said? He said AD and DB are equal. Makes sense, right? You can say it backwards too. If AD, well, also D has to be between A and B. So if D were floating up here, these might be equal, but it's not, it wouldn't be the midpoint because it's got to be directly between. So it's got to be on the same line. You guys remember between from yesterday? So yeah, it's AD DB, whoops, I don't want that actually. AD equals DB and D is between A and B. Alright, so yeah, midpoint is what you might guess. So how could I find the midpoint of AB up here? Like where would it be? How could I find the midpoint of AB on this number line?
You count to B and then you count to C. Oh wait, hold on, what are you saying?
Midpoint of AB, segment
Oh.
AB.
You would divide it by 2.
Divide the length by
Okay, divide the length by 2. Like it's 5 all the way from here to here, right?
Yeah.
Divide that by 2 is like 2.5. So it'd be 2 plus 2.5. Be like 4.5. There is a easier way to do it though. Anybody have any idea? So the midpoint is like right between. How do we find numbers right in the middle of two other numbers?
mean.
Yes, mean, which means average. So you add these two together and divide them by 2. And that gives you the midpoint. Does it work with negatives? What's the midpoint of segment CB? Negative 2 plus 7 divided by 2. That would equal 5 divided by 2, which equals 2.5. Does that seem right? Is 2.5 the middle of CB?
Yeah.
Yeah, it is. It's kind of hard to tell, but yeah, it is. Tell exactly, but if I drew my number line nice enough, it should look like it's right in the middle. All right, so average to find the midpoint. We're also going to do some angle stuff today, really kind of basic. We need protractors. So if you're not here and you don't have a protractor at home, you're just going to have to wait till Monday to do it. There's like 10 problems with protractors, so you can still do the rest of the assignment. Okay, so an angle, you guys remember, has a side, a vertex. Should have asked you guys that one. Side, vertex, side. So what kind of angle is this, by the way?
Acute.
Acute. And how would we define an acute angle?
Smaller than
Right, less than 90 degrees. And what does a 90-degree angle look like?
Straight. Like
Perfect,
no.
perfect corner. It's called a what angle?
90 degree.
Right.
Right angle. Okay, that equals 90. And if it's bigger than 90,
Obtuse.
looks like that. It's called obtuse. You guys remember this stuff, I'm guessing?
Yeah.
Actually, it's not just bigger than 90. It's bigger than 90 and less than 180. Because what does a 180 angle look like?
Flat.
Flat. Yeah, it's called a straight angle. So it's like going from there to there. So a straight angle is equal to 180. And they didn't name anything bigger than 180, so like this would be bigger than 180. No names for that one though. Okay, number 1, you guys ready?
Yeah.
Let's do it.
Tonight.
Probably not, sorry. I'll come to all your home games, okay? Let's turn the temperature below 100.
Please.
Okay. Oh, I should probably also mention adjacent angles. I don't think we really need this today, but we'll need it later. So adjacent angles, you guys know what adjacent means, like outside of math?
Like a cross.
Means like next to. Somebody lives beside you, or like you guys are sitting adjacent to each other. So adjacent angles are angles that share a vertex and a side. So these two angles are adjacent, so next to. That's it. All right, number 1, draw a number line and graph the points. Well, it says A is 3, B is -4, C is negative square root of 7. So how would I figure out where C goes? Any bright ideas? it's called square root. Just use a calculator. You can kind of get an estimate because 3 times 3 is 9. So it's not going to be negative. It's not going to be as low as negative 3. 2 times 2 is 4. So it's going to be somewhere between negative 2 and negative 4 or negative 3. Okay, what do they mean by graph? A is 3. Put a dot at 3. Label it A. B is negative 4. So these are not trick questions. But where is C? That is the question. Okay, negative 2.6, so that's between 2 and 3. Is that going to be closer to negative 2 or negative 3?
Negative 3.
So just a little bit closer to negative 3. And that's point C. Okay, number 3. These are super easy. State the coordinate of the point. L. What's the coordinate for L? 6. So 3A is 6. B is F. What's the coordinate for F? Negative 5. Number 5. Find the distance. So how do we find, what do we say, how do we find the distance for CK from C to K?
You would add and then divide it by 2.
No, that was mid.
Oh. Got it. You gotta subtract.
Yeah, subtraction normally. So CK, if you look at the picture up above, is C is at 0 and K is at 9. So obviously, how long is that? 9. I mean, you could say it's 9 minus 0, right? But it's a little bit obvious, so I don't think we need to do that. Number 7, how long is LF? L is at 6, F is at negative 5. So 6 minus negative 5 is 11. Number 9. Okay, number 9 is a little different. It says AF plus FC. You guys see AF and FC in the picture?
Yeah.
Well, if we add those together, what's that going to make?
Like negative.
No, AF plus FC together creates
Segment AC.
AC, right? It's called this, like this little segment equals big segment, segment addition postulate. So really, we need to know how long is AC. So from negative 8 to 0 is 8 long. Okay, number 11. See how quick this is going? AK minus CK. All right, do you guys see AK in the picture?
Yeah.
The biggest segment, almost all the way across, minus CK. So what do we, if we take out CK, what are we left with? If we start with AK, and then we subtract out CK, what does that leave us with?
Negative 8. Right.
So talking about, right, segment CA. So we're starting with segment AK, and we're removing segment CK.
AC.
So that's basically going to be the length of AC. So how long is AC? No, there's no negatives in the length. Just 8. Number 13. Okay. I gotta read the directions. Assume that T is between P and Q. So I'm gonna draw a picture. See what you're talking about. No, it's not.
Well, if you don't have a line.
Assume T is between P and Q, and it also says PT equals TQ. So what's that mean? Okay, T's in the middle, but
They're both, they're PT.
what did we say that was called? T is the midpoint. So that's, on 13, that's what they're asking. What is T in relation to segment PQ? T is the midpoint. Yeah, I kind of screwed that up. So these marks indicate that these two segments are the same. Anyway, the answer is T is the midpoint of segment PQ.
T is the midpoint.
You kind of need that picture for number 13, or 14, I mean. Okay, number 15. All right, this is the protractor part. So let's pass this out. These smaller ones work better because they fit on page better. All right. So let me get out. Let's see. We got a protractor over here. All right. There we go. Okay, so here's how a protractor works. We're going to be measuring number 15 angle NMO. So I'm just going to kind of draw a random angle here. So this is how it works. You take the protractor and you put this point right here, right on the vertex. Let's see if I can turn this a little bit. There it is, good as I can get it. Okay, so you want this point right on the vertex, kind of that intersection point. You want the bottom of the protractor, that line towards 0 degrees, you want that to be along the one side of the angle. You guys see what I'm saying?
Mm-hmm.
Okay, the other line is pointing up to the angle, to how many degrees it is. So I'm trying to measure this angle right here, right now. Let's see if I can, maybe I can. No. Okay, anyways. So if I look at my picture, it looks like it's between 50 and 60 in my picture, not your guys' picture. So it's maybe 51 degrees, or it's between 120 and 130, so maybe it's 129. So how do I know which angle goes with this? How do I know which one is right? Yeah.
If it looks like this, then it's going to be the smaller one.
Right, if it's an acute angle,
This.
it's got to be the smaller number. So this angle right here is like 51 degrees. Okay, well, why do they have this big number written over here also?
In case it's an obtuse.
Okay, if I was measuring this angle on this side, like from here to here, that would be the big angle. So this big obtuse angle is 129. So if you're measuring this angle, it's the 51. If you're measuring the obtuse angle, it's the 129.
That's funny. 15, 51. Number 15.
Okay, why don't you guys try, everybody try, maybe you already did, see if you can get number 15. And I'm gonna say it, your answer has to be within 3 degrees to get it right. And I told the other class, if you get all 3 evens right, like perfect, I'll give you a bonus point. But it's pretty hard, I'll tell you that.
Yo, let's look it up.
But let's see if we can get close on number 15. And if not, I'll try to see what you were doing wrong.
Actually.
Alright, do you guys have an answer on 15?
Yeah.
Yeah.
Okay, the book put 52 degrees.
Bro, whoa. I got 54.
54 is close enough. What'd you put?
54.
54.
I don't think I did that right.
Okay.
I got 52.
So we're doing angle MNO, so this one.
Yeah.
So it should look about like that.
Yeah.
And it's between 50 and 60, not 50 and 40. So it's a little bit closer to 50, so it looks like about 52.
Oh, I was looking at it here.
Okay, why don't we use these numbers? That would be for the obtuse angle.
Okay.
Alright, Paxton, did you get close?
52.
Like you had it perfect, or you just wrote it after I said it?
I just wrote that.
Okay.
I was trying. I just wasn't-
Try number 17, so you can get within 3 degrees on that one. QMN, it's a very large angle, right? So you should expect something closer to 180.
What is it?
Let them finish first. If you're done, might as well go ahead and, I mean, you can start doing the 19 or 16 or 18.
Bro, number 18 is difficult.
Okay, Paxton, did you get an answer?
157.
Exactly right. Ding, ding, ding.
Yeah, 158.
Okay, you still get credit for 158, but if you want the bonus point on it's the 3 evens, you have to get perfect. So it's hard.
I got 155.
155 still, as long as it's within 3 degrees, I'm gonna say it's okay. Okay, number 19, let's do that one real quick and then we'll move on.
Can I say it when we're done?
All right, Roman, what'd you get?
126.
Not exactly, but you got credit.
127.
Getting warmer. 128 is what they put.
Dang it! I measured it so
So
well.
carefully. I know, it's really hard. Especially because those protractors are pretty tiny. But, yeah, it's 128 is what they put. So, yeah, it looks like you guys got the hang of it. Okay, on 21, are you guys ready? It says to draw your own angle and then label what kind of angle it is, acute, right, obtuse, or straight. So 21 says angle TXY equals 55 degrees. So how are we going to draw the angle ourselves? That is the question.
Like this.
What does this do?
We use a protractor. Which Jordan? Can you help me on number 18 then? Because it's like, instead of like starting at L or N.
Oh yeah, okay, 18 and 20, yeah, I think, I needed to say that. 18 and 20, the angles are sideways. So you need to turn your protractor so that the bottom of, like one side of the angle is along the bottom of your protractor. So you have to move your book or protractor a little bit. Okay, 21. You guys watching now? Don't get lost here.
Oh, okay, yes, I'm watching.
Okay, how do I draw a 55 degree angle? using the
Draw the
protractor.
dot
Oh,
in the little dot.
Okay,
thing.
use the protractor as like the bottom, as like a straight edge, to draw a straight line. That's step one. You guys have a guess what step two is?
Draw the dot in the little dot thing.
Okay, this is gonna be the bottom of my angle, and I'll use this as the vertex. So I'm gonna put the protractor right there where the corner is. And then since it's supposed to be 55, there's 50 and 60. I'm gonna put a mark where 55 should be kind of missed.
you see where 55 should be?
Yeah.
Plus,
Okay, then all you have to do is connect the dots. Connect the end of your line with the 55-degree point. They probably labeled it when they did it TXY. I guess I'll go ahead and do that. And they also say you have to name what kind of angle that is. So what kind of angle is that? Acute.
It's a cute one.
Number 23 is 180 degrees. I'm not going to draw that one, but what would that look like?
It would just literally just look.
It'd be a straight line, yeah. Straight angle.
easy.
So just use your straight edge for that one.
For what number? Oh. Yeah.
Okay, 25 through 28 says find the distance. The numbers are just bigger, so you might want a calculator. But how do we find the distance between the points on a number line? Guys, wake up. How do we find 25 through 28? How do we find the distance between those points?
Subtract and add.
Wait, okay, I got it. Alright, so 25. We got.
So 3 or 8 and 39.
You subtract.
Yeah.
Yeah, just like we did at the beginning. Okay, so, yeah, 25 is 31. Jumping down to number 29, says use a protractor to draw the angle that's congruent. Basically, you would just measure the angle and then repeat it, but I'm just going to say you can just measure the angle
And just get the angle.
and say what kind of angle it is, just like, so 29, say it was like 125 degrees, it's not, but, so just put 125 degrees and
we're only going to
twos. We're only going to 30. So all you have to do on the last two is measure the angle, how many degrees is it, and then what kind of angle is it?
So 22 is cute.
22. 22?
Yeah. Or 29
No, it's not acute.
It's all twos.
It's bigger than 90. All right, that's it.